It's 6:30 a.m. Larry Scott is flying in a Navajo Chieftain at 130 knots and 8,000 feet. His destination, Ground Zero at the southern tip of Manhattan.
This is actually an infrared image of the ground as we're passing over it.
Using the latest in laser and heat imaging technology, his mission is to help ensure the safety and efficiency of recovery efforts at Ground Zero.
Yeah, we're looking for the winds at 3,000 feet. If you can find someone that has those, that would be great. Thank you.
And this is the precise line navigation. And you can see as he lines these, brings these two indicators into coincidence, he's within literally a few feet of a predetermined track. This is the camera. It's all primed and ready to go. The video is recording. Engage the laser recording. This is Ground Zero. These are the two federal buildings. Communication buildings is over here. Number 7 just went out of sight. I've seen this so many times, I just look for a couple of key buildings. This is the fire scene right in here. These glowing hot spots. You can actually see some of the water jets. There's building 7.
Scott's mission has 3 vital components. He collects digital pictures to help plan the removal of debris. He maps the site with a device called LIDAR, a sophisticated laser that digitally defines the buildings and rubble heaps. And he records thermal video, a crucial guide to determining the location of ongoing fires. Scott is a technician with EarthData, a cutting-edge firm working closely with the New York State Office for Technology.
There are still extensive fires burning under the site, and what we're able to do each day when we fly is monitor the change in those fires. So if you've got firemen or anybody around that area working, they could in fact be badly burned by a sudden flare-up.
The LIDAR is the most sophisticated tool for pinpointing potential danger spots.
It's the laser scanner, and it has an infrared pulsing laser and a scanning mirror, and actually measures the topography of the ground. And it's very high speed. It collects like 900,000 points a minute, and the points are just samples of the ground, which goes into making the topographic maps.
The result of this hyper-fast laser is a map revealing the heights and movement of remaining buildings and rubble piles.
We're also monitoring the rubble pile each day to see if there is actually, as I said earlier, condensing rubble, or if rubble's moving in any particular direction. But what we have found out is that the rubble pile is pretty